In this tutorial video, we'll try to do a slightly more complicated case study for nested if statements. And I want to show you actually two versions of the if statement just to show you the different meanings for different constructs for the if statements. And we're going to see that for this particular case study, one version will be appropriate and the other version will be inappropriate. Okay, that's kind of the roadmap. But we'll show you the inappropriate version first. Okay. So let's create just the project first for this particular lab 1 to begin with. So you can go to File, New, Java Projects, and you can type, let's say, lab 1, the current week's lab. Okay, you can say Finish. Okay, we got a new project over here. Of course, I'm going to rely on you to actually push, add commit and push every change you make back to your GitHub account, the private one. Okay, so let's now, first of all, let's create a new class over here. Okay, let's say new, and then we can say class. Let's make a little bit of interesting name. Okay, so let's say bank app 1. Okay, and then I would say generate a main method over here. Okay, so I'm going to show you two versions over here, right? The main purpose for showing you the two versions is to show you the different construct for the if statements. And also to show you for this particular application, maybe one version is more appropriate than the other. Okay, but there's no absolutely right or wrong if construct. It really depends on what you need. Okay, that's something I want to emphasize first. Okay, so now let's define what a problem is before we try to go ahead and do the two versions. Okay, so now let's see what the problem is. Okay, you can do some Java comments over here. Okay, so now let's see what the problem is. Okay. Basically, we want to do something kind of similar to what you did previously, but let's just redefine the problem. Okay, so number you'll prompt the user. Let me just say different step. How about that? Okay, number 1, you'll prompt the user for an initial balance of their bank account. Okay, and then I'm going to document that over here. The balance, whatever balance they enter, must be strictly greater than 0. Otherwise, it's considered as an error. Okay. Number 2, once they actually enter their bank account initial balance, we're going to prompt them for what kind of transactions they would like to perform. Let's make it simple. Let's say either deposit or withdraw. Okay. So prompt the user for a transaction. Okay, and then let's say the transaction over here can be, let me say whatever, let's say transaction they have, let's say transaction should be either, okay, let's say D for deposit. So let's just make string so that we can just have input the next line. So that's easier. We don't have to worry about character for this particular tutorial video. Either D or W for withdraw. Otherwise, it's invalid. For example, if the user enter capital D, so it's case sensitive. If they enter capital D, capital W, or they enter withdraw, they enter deposit, it's all considered as invalid because it has to be exactly D verbatim, lowercase, and it has to be W lowercase verbatim. Okay, so prompt the user for the transaction, and then prompt the user for an amount. So if the previous transaction they enter was a D, so that means the amount should be a deposit amount. If the previous transaction they entered was a W, then the amount should be for withdrawal. Okay, for the amount. So now over here, what you can say in both cases for deposit and withdrawal, amount first of all should be let's say positive. Okay, you cannot really withdraw 0 or deposit with 0. You also cannot deposit negative number. You also cannot withdraw negative number. Okay, gotta be strictly positive. Okay, the amount should be positive. You know, let me make it even more mathematical for you. Should be strictly larger than 0 in both cases. However, in the case of, let's say, withdrawal, the withdrawal amount must be affordable. Okay, we can say the amount. You know what? Let me just separate them into separate points over here, so it's easier for you to document. You can see I'm just trying to document the requirements for the problem before we try to code. It's really important that you should not always dive into the coding right away. You really want to make sure you clarify yourself what kind of problem you're trying to solve. It's really important software engineering practice. Okay, In both cases, the amount should be larger than 0. Okay, and then in the case of withdrawal, okay, in both, let me just make it better for the formats for you. Okay, amount should be larger than 0. In the case of withdrawal, the amount should be, let's say, strictly less than the current balance. Okay, let's say if you got $100 in your bank account, you can only withdraw from 1 up to and including 99. You cannot even withdraw 100 because that will give you the resulting balance being 0. That's not allowed. Okay, so now let's say in the case of deposit, let's say this. Let's say we introduce just a concept over here to say for this particular bank, they simply have a maximum bank account balance for you. Let's say it's only up to 1,000, for example, right? So you cannot have more than $1,000 in your account. Let's say that's kind of the particular account you're applying for. Okay, deposit. Let's say so that means the current balance plus whatever amount you're trying to deposit into, the resulting balance should be, let's say strictly, let's say less than or equal to 1,000. Okay, let's say that's something we want to fix. Of course, if you want to make your app fancier, you can simply prompt the user rather than, in addition to just balance, you can also prompt them for, okay, what kind of a maximum balance do you want to have for your account, right? What's kind of the maximum? Okay, but for now, I'll just assume it's less than or equal to 1,000. Okay, so these are kind of the constraints we have. You can see it's kind of make the bank application a little bit still very simple, but definitely more interesting than the previous one we do, since you learned about if statements. Okay, so now we prompt the user for initial balance. The balance must be strictly positive, and also the kind of transaction can either be D or W, and also we got these constraint over here, right? So that's the problem. Okay, and then finally we can say number 4, perform the transaction accordingly, right? Either deposit or withdraw, and output the resulting balance to console. Okay, that's kind of the problem. Of course, if they have any of the, if they violate any of the constraint, for example, if the initial balance is less than or equal to 0, in that case, your app should really not go ahead and try to print an error. Okay, let me just say one more thing. So now, note, as soon as an error occurs, your app should print out an error right away and terminates the app. Which means if the user wants to withdraw a negative amount, you should definitely abort right away to say, no, I'm afraid you cannot do that. So you're going to launch the program again to try with some valid input. Okay, so that's the problem we're trying to solve. Okay, before we try to code it in Java, please make sure you understand the constraints I have set up over here for you. Okay, so now let's see how we can solve this in Java. Okay, let's do the stuff that we can do immediately, and then we'll focus more on the logic in if statements. Okay, so now we're going to declare our scanner over here as usual. Okay, control space, and then you can import. Okay, scanner input is new scanner, and then it's going to read from system.in, the keyboard. Okay, and then as the last line, I'm going to say input.close. Okay, so we can put things over here, right? Now, step number 1. We want to prompt the user for an initial balance for their bank account. Okay, why don't we try that? Okay, system.out.println. Okay, so now we can say enter. Let's make sure. Let's just make. We can make a double. That's fine. Enter a double balance. Okay. Enter a balance which enter a balance, for example, which can be, for example, let's say 200.45, right? So that means there can be, you can expect some fractional part to the balance, of course. Yeah. Oh, actually, they want to be logically correct. Since we say that you cannot withdraw after the deposit. It can be only up to 1,000, right? So now maybe for the initial balance, we want to say balance larger than 0, and so balance basically has to be in between. Okay, let me put it this way. So 0 should be, balance should be strictly larger than 0, and then it can be less than, must be less than or equal to 1,000. How about that? Okay, so that will make it a little bit more robust, the logic. Okay, so now enter the balance, for example, 200.45. Okay, just how we prompt the user. Okay, and the user is going to enter some double, right? So we can say double over here, and then we can say balance is assigned to input dot next double. Okay, so now let's do some error handling right away. Basically, we want to say if the user enter a balance that is not within this interval over here, we have to give them an error, right? So now let me just actually we'll discuss a little bit more in the class later, but now let me just do the simplest way for you to think about, since it's only a tutorial for you to get hands-on experience. Okay, so basically we want to say if the balance is in between 0 and larger than 0 and 1,000, if that's in this interval, that means we can go ahead and actually do something. Otherwise, we should print out the error, right? That's what we're going to do. We can say if, over here, we can say if the balance is larger than 0, okay, or you can say 0 less than balance. They are equivalents, okay? Maybe just put it this way so it looks more like your math. So balance is large, 0 is strictly less than balance, and, right, remember we said in the previous tutorial video, if you want to set up some interval, you have to use conjunction. If you use disjunction, it might end up being true, okay? So you can refer to the previous video just to draw your connection to the previous video. Balance strictly larger than 0 and balance less than or equal to 1,000, okay? If this is the case, so this means it is valid initial balance. Otherwise, we're going to print some error to the user. System.out.println. And then we're going to say error initial balance over here plus, okay, let's print out the amount, which is the one the user just entered, plus, okay, is not between, it's not in, I'm sure maybe in your math class you learned about open and closed interval, right? Let me be a little bit more precise. So 0 should not be included, and then 1,000 can be included, right? So you can see the left end, it's open interval, okay? And the right end is closed interval, right? So that's something you learn about in math. So I just want to be a little bit more precise. It's not in this particular range. Okay, so that's about the first error handling over here. Okay, let me just go on a little bit. Okay, let me, again, as I said, the main purpose, of course, I want to show you some more complicated app. I also want to show you different ways of writing valid Java program, but the behavior, one version may not be what you expect, the other one might be what you expect, right? I want to show you so you can see the meaning for different if statements, okay? I'm just going to continue. So this is basically we're saying this. If it is valid, then we're gonna do nothing because we don't print out the error message. Otherwise, if it is not valid, then we're gonna print out the error message, right? This one is very easy. And then we continue, okay? What about the second step? We're going to prompt the user for a transaction, okay? And then we're gonna prompt the user to do that, okay? You might already realize this version may not be exactly right, but you know, it's okay, hold your thoughts. But I would say still continue with this video here because I do want to show you the difference between multiple if statements and a single if statements, okay? That's something I want to show you eventually, but let's just go on with the tutorial video, okay? And then we'll say, we're gonna prompt the user for some action, right? Okay, let me just use this. Actually, I can just type it again. So I can say system.out.println. I can say enter a transaction type. Okay, and then you want to tell the user what they can type, right? So now I want to show you a little bit usage for the string. Okay, for the escape sequence. So somehow we want to say either D or W, right? you may want to tell the user the D and W must be verbatim, so you want to quote them, right? However, as we said in the class, if you simply say something like this, right, it is not going to work because the computer will be very confused. Because over here, the quote over here, should it be the end of the quote that matches the beginning quote over here? Or should it be the start of the quote that will matches another quote over here, right? It's kind of confusion over here. So whenever you want to have string literal that contains quote, for example, or single quote, you have to use escape sequence. I'll show you exactly how you can do it. You got to put backward slash and backward slash over here, or W and as well. Okay, that's something I would like you to really try and play with it, okay? The best way to understand escape sequence is try it out and see what a console output is. That's the best way, okay? In the class, we talk about /n for new line. And here we'll talk about / double quote for double quote. You will see that in the console output. Enter a transaction type. Okay, let me just put it in parentheses maybe here. Okay, so you can see more complicated program over here. Okay, which means you can enter either D or W. Okay, let me just get rid of the space over here. Okay, it can be D or W. Let me just close the updates. Okay, so now the user can enter. So now string, I would say type, the transaction type, is assigned to input dot next line. And of course, remember what we said before. Okay, let me remind you again. Okay, again, this is no issue for the scanner. Every time if you have input the next line that comes after input the next double, you must make sure after the input the next double or input the next int, put another line to say input dot next line. Okay, I know many of you already have seen this issue already in your lab exercises if you forgot to do this, so make sure you remember it. Okay, so now enter a transaction type. Over here, what I will do is the type. So now how do we handle the type? Basically, you want to say if the type is either D or W, then we are okay. Otherwise, we should print out an error message, right? Let me show you maybe, of course, you got options over here. Either you can use the logical OR to say if the type dot equals D vertical bar type dot equals W. In that case, you will have a single if statement. Let me show you first. But I want to show you the little bit more sophisticated version. So you can say either if the type, and remember what I said in the class. For this course, whenever you want to compare string values, always use the equals method. Okay? To compare character, integer, boolean, double, use the equal sign. Okay, always keep this in mind. So now we'll say type dot equals over here, and then we say D is either that or that. Okay, I will let me write it down first. Type dot equals over here W. If it is a valid transaction, and then we don't print out an error message, right? Valid transaction type. And then I would say else over here. Otherwise, we can say, let me just copy this line here and modify it a little bit. Okay, let me maximize this. Okay, that'll be easier for you to read. And over here, I can say valid transaction type. And then I can say the type over here, the one you just entered. Okay, see the type over here is referring to the type over here. It's not. Let me put it a little bit better. It's neither, okay, D nor W. I want you to compare when we see the console output. Okay, in case I forget to emphasize again, please make sure by yourself. I want you to compare the console output for this versus this. Okay, I want you to pay attention to that. Okay, make sure you know exactly how each one will work. Okay. Valid transaction type either D or W, okay, and then this means valid transaction type, so we don't have to print out any error message. Otherwise, we print out the error message. Okay, the same logic as before. However, now, of course, you can keep this one over here. So I will just put this one in comments, right? What I can do is I can just make it if else if, okay, to show you both versions. So the one I just commented out, this one works, okay, but I'll show you another version. You can say type dot equals, and then here I can say D, okay? Else if, Oh, actually, I forgot. You know, it's a very common mistake. Make sure you always have a pair of brackets over here, right? This is beginning brackets, and this is the ending brackets for if. Okay, and then we can say else if type dot equals, and then we have W, right? Okay, and then valid transaction type and either D or W. This is also valid transaction type. Of course, what I show you in this version over here, I simply collapse these two conditions over here to say it's either D or W that we consider as valid. Otherwise, it's not invalid. Okay, so they are logically equivalent. Okay, you can choose either version, but you should know both, of course. Okay, that's about the transaction type. And then after this, what we're gonna do is, after this, so let me just make the comments a bit better for you. Okay, so now what I would do is, since we got the step 1, 2, 3, 4, different types. So now what I will do is I'll put some comments over here for you. Different stage. Stage 1, which means we're gonna prompt the user for the initial balance. Okay, so over here this is stage 2. Okay, of course, if you want to make the line fancier, you can do something like this, for example. So it's easier for you to see that. Okay, I'm just showing you one style that I prefer. You can definitely make the comments in whatever style that you yourself prefer. Okay, so that's stage 1, and this is, beg your pardon. Okay, let me just copy and paste this one here. That'll be easier. Oops. Okay, that is stage 2 over here. Okay, so now let's go to stage 3, which means we have to handle basically the amount, withdraw, and deposit, right? So now we're gonna prompt the user for an amount. Okay, so what I would do over here is stage 3. Stage 3. Okay, and then we're gonna prompt the user for an amount. System.out dot print line. So now we can say enter an amount for either deposit or transaction, right? Enter an amount for, you know what? I will make it a little bit, I'll make it not so ideal for you, okay? But you can try to improve it by yourself. Enter an amount for whatever type it is, right? If that's D or W, right? Enter an amount for the type. Okay. Oh, notice one thing. You can see that over here, this is a string literal because all the string values over here are quoted inside the double quotes. Similarly, this is also a string literal because the colon over here is quoted within the string literal. And the type over here is not quoted in the string literal, it's not quoted in the double quotes. This means type must be referring to a variable that's declared previously. In this case, indeed. If you move your mouse over the type, you will see that the type, let me just put a semicolon here so everything compile. And then fix the typo. Okay, if you move your mouse over the type over here, you can see that it actually highlights over here where the string type is declared, right? Just notice that highlight from Eclipse, which is very useful. You always want to know what the type is for each variable. Data type is a very important concept for you to understand. If you're not so confident, refer to the lecture and the slides about data type. Okay, so enter an amount for the type, and then we're going to ask the user to actually enter an amount. So, of course, it can be double number, right? So we can say double, let's say amount is assigned to input dot next double, and before we forget, we always say input dot next line after input the next double or input the next int. Oh, beg your pardon, it should be input dot next line, not next line. Next line over here. Okay, so now we got the amount over here. So now we may have to do a little bit. So this is the place where we can do some nested if statements, which I want to show you. Actually, the nested if statement in some ways is very natural. You just have to get used to the syntax. So what we have so far, we say if some condition we do something, else if some condition we do something, right? And whenever we inside the curly brackets block for each branching condition there, we do very simple stuff. However, the branching, the block can also contain another if statements. Okay, it's called nested if statements. Okay, that's something I want to show you. Okay, so what we can do now is we can do it this way. If the type happens to be dot equals, let's say D over here, okay, then we do something. Else if the type dot equals over here, that's W, then we do something else, right? So now, over here, you can see that in line number 61, what should we do? Basically, if the deposit is actually, if the type of the transaction is deposit, what do we have to check? First of all, in that case, we have to make sure the amount is larger than 0, and then for deposit only, we want to make sure the balance plus the amount should be less than or equal to the maximum balance level, right? That's only for deposit. This constraint should not be applicable in the case of deposit. On the other hand, if we go inside this particular branch over here, we have different constraint to check, right? In which case, we had to make sure, again, we got to make sure the withdrawal amount is larger than 0, and also the amount should be less than balance, so it's affordable, right? So you can see that depending on whether the type of the transaction is either D or W, we have to do different things, okay? And over here, that's why nested if statement will be useful. Okay, let's see. So now I'm going to do something that's called nested if statement. So in the case it is deposit, then we can simply say if the amount is less than 0 over here, is less than 0, then we do something over here. Okay, else if, okay, things get a little bit complicated, but that's okay. You know, that's why we want to really go over with you thoroughly this example and then improve it later. And then we say that, let me see what the constraint is. It should be the for the deposit. Let me just copy and paste that, okay? And then we got balance plus the amount should be less than 1,000. Okay, actually, you know what? Logically speaking, what I should say is, in the case of deposit, okay, amount should be larger than, yeah, exactly. So now we want to say under what circumstances are we going to give you an error, okay? We know that this is what should be the case, right? The balance plus the amount should be less than or equal to the maximum balance level. So when should we give an error? We should give an error if this is strictly larger than 1,000, right? So that means we should give it an error. If the amount is actually less than or equal to 0, let me just, we'll go over this logic here a little bit more detail in class. You can think about when we will consider that as a valid input if amount is larger than 0. So when do we consider amount as an invalid input? It is when amount is less than or equal to 0, the negation of that, okay? But anyway, so I just want to just show you what the condition should be. You can figure out the logic or follow the lecture a little bit later. Okay, so over here we say amount is less than or equal to 0. So in that case, we should give it an error. Okay, in that case, we can say system.out dot per line, and we can say error. Okay, and then we can say deposit amount is not positive, right? I'll just give you one example error message, okay? And over here, you can say, over here, error, deposit amount is too large, okay? And otherwise, we can do the deposit. How do we do the deposit? We simply say the balance that we have over here, right? Remember, the balance is the balance that we read from the user initially, right? In this particular line, okay? So what we'll do is balance is assigned to balance plus, right? Balance B-A-L-A-N-C-E plus the amount, right? And let me show you also something that we learned in the lecture, okay? Let me comment this out. It would be equivalent if you say balance, since you can see the balance occur over here and over here, right? We said we can simplify that. Plus equal amount. That also works, okay? So now we have a similar logic, similar but not exactly the same, for the withdrawal. So you can simply just copy and paste this block of code, and let's see what happens, okay? I'll just copy this guy here, and then I'll put it here. Okay. So now if amount is less than or equal to 0 for the withdrawal, and we can say withdrawal amount is not positive, right? So the user knows exactly what they have done wrong. And now over here for the second constraint over here, let's see what that should be. Okay. So over here, remember we say that in the case of withdrawal, the amount should be strictly less than the balance. So this is what we expect the amount to be for the normal case. So what should be the error case? It should be the negation of less than, which should be larger than or equal to. So when should we have an error? When the amount is larger than or equal to the balance. When the amount is larger than or equal to the balance. We'll talk a little bit more about the negation of relational operations or logical operations later in the lecture. So just for this example, just try to figure out exactly what I'm trying to say here for the logic. And then over here you can say withdrawal amount is too large because we just cannot afford. And then finally, well, for the else part, we can either say balance is assigned to balance minus amount, okay, for the withdrawal, or we can say minus equal. Okay, this will also work. Okay, good. Okay, that's kind of what I want to do. And then finally, we can say, we can output the balance, right? System.out dot print line. Okay, and then you can say resulting balance over here, and then balance. Okay, that's exactly what we have. Okay, of course, you know what? We can even make it fancier. Resulting balance after performing transaction of, and then I can put type over here, which can be D or W, transaction of type, and then with this much, this amount of money. I believe for the dollar sign, okay, for dollar sign you can just put it, that's fine. With dollar sign, and then the amount, and then we can put a colon over here, okay, and then we can say plus, right? It kind of looks complicated, but you know, since we learned about how to use concatenation, how to use mixed strings and numbers together, so this one shouldn't be too strange to you at this point, okay? So that's kind of the last line for the program, right? You can see the different stages we have. Okay, we got 3 stages, and of course stage 4. Okay, finally stage 4. But somehow in this case, stage 3 and stage 4 are kind of mixed together because I also did the correct operation over here. But you can you will see exactly how it works in the runtime. Okay, let me just also make a comment over here, stage 4. Okay, stage 4 over here. Oops. Okay, let me just type it out. Stage 4. Okay, so now, so these are the 4 stages for the program, and then even before we run the program, you can already try to anticipate yourself. Is this really going to achieve what we wanted to achieve? Okay, my answer would be no. Okay, why? Notice that we say that here, as soon as an error occurs, your app should print out an error right away and terminate the app, right? That's very the key of the requirements, right? So that's why I want to show you this version over here, which somehow is doing on the right track, but the way we organize the if statement is not exactly correct. That is why I want to show you how you can, why this version is actually wrong, and I'll illustrate it to you. And then we want to go over we want to trace a program for some cases, not really thoroughly, that will take too much time. I'll just trace the important cases with you. You can trace other cases by yourself. And then in the next video, we'll try to improve this version by using some other shape of the nested if statements. Okay, but again, so far, hopefully you're comfortable with this nested if statement, which means this particular nested if statement is only executed if this branching condition here is true. Okay, similarly, this particular if else if statements is only going to be executed if this particular branching condition is satisfied. Okay, it's kind of selective, right? So now that's something I want you to pay attention to. Okay, let's now basically just run the program. I will just try a few test cases with you, and then we'll see what happened. Okay, so now let's do the following. Let's run the program, enter a balance. Okay, let me just try some illegal outputs. Remember, if I enter some negative number, the program should terminate right away. That's what we set what the requirement is, right? As you can see that. Should print out an error right away and terminate the app. So now what I would do, go back to console over here. If I say minus 200, okay? So that means I should get an error and the app should terminate right away. But let's see what happened. Error, initial balance minus 200 is not in this particular interval. That is good. However, even though the initial balance is already negative, it still asks me to enter a transaction type. No, that's not the case because the program is supposed to have terminated already. So this is incorrect behavior number 1. Okay, just keep that in mind. I'm going to trace several cases with you together. So this is not good. Okay, okay. Let me right click and say clear. Okay, and let's do another one. Let's say I run again. Let's say I put the initial balance to be 200. Enter a transaction type. Okay, so now D or W. Let me say T, for example, which is invalid. So now what do I expect to see? What I expected to see would be 2 things. Number 1, there should be an error message to say T is not a valid transaction type. Number 2, the program should terminate right away without asking me for any amount for the transaction because T is invalid. However, when I say error over here, when I say T and then click enter, they will say error, transaction type T is neither D nor W. This line is fine. However, you can see the program over here is not terminated yet, right? That means over here, the program is still mistakenly asking me for an amount for the transaction. That is wrong. The program should have terminated already. So that is incorrect behavior number 2. Let's very informally look at the code structure to see why so far for these 2 incorrect behavior I just illustrated, why are they the case, right? Let me give some intuition and then we're going to trace the code more thoroughly. Okay, so now you can see that over here. I want you to see very clearly the relationship over here. You can see we got if else, and also we got another enter transaction type, right? Remember when the balance that we entered here was let's say minus 200. Apparently minus 200 would not satisfy this range constraint. So which means we should print out the error, right? However, remember what we said before as the requirements. We say that as soon as an error occurs, your app should print out an error right away and terminate the app. Which means after we print out this particular error message over here, we should not allow the program to do anything else. However, you can see that this is the current if statement that we are dealing with, and after the else part, it's just only this part of the code is done. So of course, from top to bottom, that's the sequential execution we talked about before. After this if statement, of course, we go to another one, and this one is unconditional. We just execute it anyway. So that means there's something wrong logically. The syntax is correct, but it's just the way we organize the code is not correct. So it's a logical mistake. What we should have done is to say, we only execute this particular line to ask for a transaction type if there was no mistake on the balance value. So this basically the rest of the program starting from here until the last line should have been put inside this if block over here. So conceptually, I hope you can see the issue over here. But I will illustrate to you on the iPad visually a little bit more. Okay. Similarly, for the second kind of error, let's say we enter a type over here that is neither D nor W, right? So this block of code, I want you to consider this block again. Similar issue. Over here, you can see if that's neither D nor W, that means we print out the error message. But this is this single if statement, if else is considered as a single if statement. It's only this block of code. So as soon as you're done with this error printing over here, it's only that this particular if statement is done. However, we'll still go on to the next line of the code for sequential execution. So we'll still enter the amount, even if the transaction type is not valid. That's how the incorrect behavior number 2 occurred. So what we're going to do is, I want to illustrate another thing about a program which somehow is correct, simply because the code structure is really the one we want to change into, just for that small part, okay? Let's say this. Let's say we enter the initial balance being valid. We also enter the amount. We also enter the transaction type being valid, let's say W. And now let's say we go to this particular else if, right? Because type.equals w will give us true. Okay. In that case, let's say if the amount is somehow negative, for example, let's say we say minus 200 for the withdrawal amount. What's going to happen over here? Think it this way. This if, else if, and else is a single if statement. And as we discussed before in the tutorial video, for a single if statement, you only execute exactly one branching condition action. Okay. So now if the amount happens to be minus 200, that means minus 200 less than or equal to 0 will be true. That is the first satisfying branch, which means we will execute this particular branch code over here and then ignore the rest of the if statement, which means this action over here about reducing the about subtracting the balance from the subtracting the amount from the balance will not be executed. So that is correct. So which means somehow this is really the correct structure we want to have. We want to say either we print out an error, or we actually do something correct. So that's kind of the structure we want to change our code into. Okay, that's something I will do in the next video. For the current video, I just want you to realize that the behavior for if statement, you really want to know what you're doing when you do your assignments. Okay, so now let's illustrate one more. So that's so we talk about two incorrect behavior. I'll illustrate a third behavior to you to see if that's correct or not. Okay, let me rerun the program over here. Let's say the balance is correct. Okay, transaction type, I would say W for withdraw. So which means I will go into this particular branch over here, right? Okay, and now let's say I enter amount being minus 200. Okay, that's what I would do. Okay, I say minus 200. Let's predict what's going to happen. If I say minus 200 over here, minus 200 less than or equal to 0 is going to give me true. That means I'm going to execute this particular error condition. Now the question for you, are we still going to execute else branch over here, which will subtract the amount from the balance? The answer is no, because the whole thing over here is a single if statement. Only exactly one branch will be executed, only one branch action. Okay, so that will be okay. So let's see over here. So as soon as I say hey enter, it's going to say error, withdrawal amount is not positive, and the initial balance simply keep the same as before. And this is as expected, because even though you give the correct, you give some valid initial balance, you give some valid transaction type, but the amount is simply just not right. So we wouldn't do any withdrawal for you. So your balance remain to be 200. Okay, so you can see so far we illustrated 3 test cases for you. The first 2 are incorrect behavior. The final one is correct behavior, but we want to learn from that. Okay, so what I would do is I want to switch to the iPad and show you the 3 cases one by one. Okay, so you can see more clearly the execution flow. Because now the code is getting a little bit too big, so I only copy and paste the relevant fragment to illustrate. That will make it easier. So what I would do, first of all, what I would do is I will only, let me just copy this part over here for the case number 1. I will simply go for this one over here until enter a transaction type. Okay, let me just say, let me go up to here. Okay, this will be enough. Okay, let me go to my iPad here. Okay, and then let's see test number 1. Okay, let me first of all paste my code fragment over here. Okay. Okay, let me make it bigger for you. Okay, this is case number 1. Okay, so now, and I'm going to re-emphasize my point. Okay, let's talk about 3 test cases. Okay, so let's say first one I'll use pink. Let's say test number 1. Let's say the balance the user is going to enter will be simply just minus 200. Okay, as we just said. Okay, let me just make it boxed. So this is a test we want to do. So what do we expect to see? We expect an error message to be printed, and also we want the program to terminate right away without continuing to do anything else. Okay, so let's see exactly what's going to happen. So when we try to execute this line over here, prompt the user for a balance over here, and then we'll say input next double, the user is going to enter minus 200. So that means balance is going to store minus 200. So far, so good. And then, of course, don't worry about this line here. You just work around for making the scanner to work. More importantly is this line here, okay? Let's try to evaluate that. So balance is now minus 200. And balance is also minus 200, right? 0 less than minus 200 and minus 200 less than or equal to 1000. Let's evaluate that together. And this one here, 0 cannot be less than a negative number, so this must be false. And negative number less than or equal to a positive number, that should be true. So now, according to what we said before about relational operator, logical operator, there's something you should know. For conjunction, at least one side is actually false. Overall, it's going to be false. So that means over here is going to be false. False, which means we are not going to go into this branch. Instead, we're going to go to the else branch. Since there's no else if, so we just go to else directly. So that means we're going to say error, initial balance, and the balance is minus 200, is not in this particular interval, right? So far, so good. But now, at this point, what we expect to see is we want the program to terminate right away without doing anything else. However, you can see that that's something I want to emphasize to you. I want you to notice that this part of the code over here is considered as a single if statement. A single if statement, which contains two parts, if part and else part. Okay, and a single if statement has a very simple meaning. When you got so many branches, in this case, either this branch or this branch, you will execute exactly one branch, exactly one. The first branch whose branching condition is actually satisfied. Okay, that's the meaning for a single if statement. Okay, as soon as this single if statement is executed, because we execute this particular branch for test number 1, right? We are still going to remember sequential composition for the code. So we will still go ahead and actually execute this block of the code. So this is why the behavior from the external user will be very weird. That's actually incorrect, because we'll still actually, even though it's already minus 200 is being entered, and we already really entered this particular error condition over here, but we still try to print out to say, well, enter a transaction type and D or W, right? So that's why it is wrong. Okay, hopefully you can see that. That's the first trace. Again, you got a single if statement here where exactly one branch will be executed. However, after that, whatever that goes after the single if statement will still be executed, because this line here is simply not part of the above single if statements. Okay, hopefully you can see that. So let's look at test number 2, which we did on the Eclipse previously. Okay, hopefully you can see that. Okay, now let's go back to the Eclipse over here. Let's do another one over here. Let's say we want to do, let me see if I can actually put them all together. That's going to be very challenging. So now what I will do is I will simply copy the relevant code. Okay, so now what I will do is I will actually do, okay, let me just see. I want to just copy the maximum possible. Is it possible to, you know what? Let me just delete one line over here. Okay, so we can, hopefully we can see that. Okay, that's good. So this is what I want to do. Okay, so let me copy and paste this particular block of code over here, and then that's exactly what I want. Okay. Okay, let me copy that one, and then let me switch back to iPad over here. Let's do test number 2. Okay. So please be patient, because we are really trying to show you the logic for the if statements. So we want to appreciate for this particular application, the way we write a program is simply not appropriate. And then that's how we can fix it in the next video. Okay, let's try to paste it over here to the iPad. Okay, let's wait for that to react. Okay, so now let's paste it over here. Okay. Okay, this is going to be here. Okay, hopefully that's big enough for you. Okay? Okay, so now that's what we have. And now let me write down what test number 2 is. So for test number 2, what we want to do is we want to give a valid balance. Let's say balance over here is 200 as opposed to minus 200, right? And then however, the type of the transaction that we want to give, let's say rather than, so you can see it should be either D or W, right? Should be either D or W, but we give something else. What we did before in the Eclipse, I simply give T. Okay, that's what I will give. Okay, let's box it so you can actually see that over here in isolation. Okay, so let me wipe these out. Okay, so let's try to trace the code. So what do we expect to see? So this part over here, when we do 200, that one is good, that one is valid, but as soon as we see that the user entered T for the transaction, which is neither D nor W, in that case, we should expect an error message to be output. And also at the same time, the program should terminate immediately without going further. That's what we expect to see, right? So now let's have a look. The reason for the incorrect behavior number 2 is very similar to the number 1 over here, but I'm gonna repeat. Okay, it's really important to see that again. Okay, over here, let's see this. So now when we do the first line, I can kind of ignore the prompt. This is part of the screenshot. But let's say we already prompt the user for initial balance. Let's say the user actually entered over here, let's say 200. So that means 200 is going to be stored as the balance over here. And then we're going to evaluate this particular condition. Let's try again. So what we have is 0 less than 200 and 200 less than or equal to 1000. Let's see. So 0 less than 200, we know it's true. And also 200 less than or equal to 1000, hopefully you can also judge it's true. So we got true and true. That's the exact scenario that will make conjunction true. Okay, so now over here is going to be true. That means we're going to execute this particular branch, which contains nothing, which means we simply do nothing. Okay, so far, I'm gonna highlight the execution flow for you at the end. Okay, so now that means for as far as this particular if statement is concerned, and you can see that this is a single if statement, right? As we said in the previous one. So for this particular single if statement, exactly this branch is executed. So that means the else part is not executed. There's no error message printed out for balance 200. So now we go to the next line, which is outside that particular if statements. And now we're going to print out, enter a transaction type, and then either D or W. Let's say we enter, let's say T for the user. Okay, so which means the user is going to enter T. So that means the type over here is going to store T. And then we're going to go ahead and evaluate. Okay, you can see that this is just another if statement, right? This is just another if statement. Just another one. Okay, let me just be very precise to you. Over here, you can see this orange part is the first if statement we have. And the pink one over here is the second if statement. We simply got multiple if statements, but they're independent of each other. Okay, so now let's see the second if statements over here, the one in pink. So now let's say the type is now T. So if you compare the value between T and D, you know that it's false, right? So this part over here is false. And then, so that means we don't execute the body for this particular branch. So we go ahead to the else if, right? When we go to the else if, so type is still T over here. So T dot equals W, we know that it's also, they're not equal. So that's also false. So that means we also don't go to the body for this particular else if branch. So that means we have no choice but go to the else one, the else branch. So that means we're going to execute this particular line over here. So error transaction type, and this type over here is T, is neither D nor W. Okay, so now after this, so for this particular if branch, we only execute the else part, and then we go to what we expect to see now, because the transaction time is actually invalid, the program should terminate right away without continuing any further. However, this particular statement over here is completely outside the if statement, so they're independent, so they will still be executed. That's the wrong behavior. Okay, So that means over here we will still execute this line over here. Okay, as a recap, so what's the execution flow for this particular if trace? So we started with this. Of course, we execute this, and then we check this particular branching condition, which happens to be true, and then we try to execute this part, which is execute nothing, but we don't execute the else part. And then we try to prompt for transaction type over here, and then we read the type from the user, and then we check the first branching condition, which is false, so we don't execute what's inside. And we go to the else if branch, which also evaluate to false, so we don't execute the branch. And we go to the else part, and then this is where we actually print out the error message for the transaction type T, right? And then outside this, we also print this out. Okay, so this is really where the logical error is. So this is a logical error, because you should not really prompt the user for an amount when the type of the transaction is actually invalid. Okay, that's the key. Okay, so now let's do one more trace. Okay, so we can really fully appreciate what's really correct and what's really not correct in this particular first version, and then we can fix to the second version hopefully quickly. Okay, so now what we'll do is let's go back here. What I want to do here is I want to simply just go to you can see the code is getting big. So that what I want to do is just copy this particular fragment of code. You know what? If I can make this maybe just a little bit smaller, okay. Okay, never mind. If I make it too small, it'll be invisible. So what about this? Let me just only copy and paste this particular fragment of code, right? That's what I want to illustrate to you. Only this part over here. Let's say this. You're kind of familiar with the previous fragment of code already, since we did it for the two tests. So that one I can assume you're okay with that. So what I will do is I'm going to paste the code over here again. Okay, and then let's do this one very quickly, because I want to illustrate to you how this particular nested if will actually work. Okay, so now let's say for test number 3. So for test number 3, for the initial balance, we let's say the user enter, let's say 200, and then for the transaction type, they're going to enter, let's say W for withdrawal. However, for the amount they are going to enter, let's say they enter, let's say minus 1,000, right? And this is apparently invalid. So what do we expect to see? Sorry, what do we expect to see? What we expect to see is something like this. We basically want to say after these two inputs over here, which are both valid, we should be able to try to ask them about the amount. And then, however, as soon as they say minus 1,000 is actually the case, and then what we should expect to see is, well, we should really not, basically we want to make sure we print out the error message, and then we don't do the corresponding withdrawal. That's what we want to see. Okay, so let's see if that's correct. Okay, it's really correct for this particular structure here. So what we do is, let's use green. So let's say we already entered 200 and W already. Okay, let's say we did that already. And now, the type of transaction is going to be W. So now we got W over here. So W dot equals D. So what is that? So you got W versus D. So they are simply not equal, right? We always compare string values using equals. So this will be false. So which means this part over here is going to evaluate to false. If it is false, what does that mean? That means whatever that's inside this particular if, we simply bypass it. Okay? We simply don't execute it. It's completely ignored. And then we go to the else if part over here and try to evaluate this condition over here where the type is still just W. And now we're basically comparing W versus W. And of course, they are the same contents. True. So that means this part over here is T. True. So that means we are really going to execute the body of this particular if branch, which is just yet another if statements, right? So now you can think it this way. How many if statements do we have for this block of code? First of all, at the top level, we have this particular if statements, which contains the if and the else if. Okay? And for the if branch, for the orange if statements, we got just another if statement over here, which contains if, else, else if, and else as its body. Okay? And for the else if branch, for the first if statements, we got basically, let me just use green over here. We just got another if statement here, which contains if, else if, and else. Okay? So you can see the orange if statements is the top level. The pink if statement is part of the orange one, but only belongs to the if branch. And the green if statements belongs to the else if branch for the orange if statement. Okay, it sounds a little bit complicated, but please try to understand that. It's not that bad. Okay, so now because we know that this particular condition evaluates to true, that means we're going to execute this particular if statements, right? So now let's go a little bit further. Because we know that the user actually entered minus 1,000. That's what we assume, right? So that means amount over here is minus 1,000. So minus 1,000 less than or equal to 0 is going to be true. That means this branching condition is going to be true. That means we're going to execute only this branch over here. Error, withdrawal amount is not positive. Now the question is this particular else branch still going to be executed? Is this branch still going to be executed? The answer is no. It will be bypassed simply because the else is part of the green if statement over here. Because we know that this particular branch is already executed, all the other branches will just be bypassed. Okay, again, that's really about the meaning for the if statement. Please review that and make sure you're comfortable with it. Okay, so after this, we'll simply just go to stage number 4, where we simply just tell resulting balance after performing transaction of. So in this case, the type is simply W. And then the amount, we know that it's minus 1,000. And now the balance is really important because we know that we only executed this particular line. That means the balance remained to be whatever just entered before, because this part of the code is simply not executed, it was bypassed. So it remained to be 200. So that's the correct behavior. Okay, so I would suggest really review how we write a code and how we trace the code very carefully before we go on to the next video. For the next video, I'm going to show you exactly, starting from this code, how can we improve it to reorganize the structure a little bit so that we can have a correct behavior. Again, this first version here, you can see there's no red cross around the tag over here, which means it compiles and also it can be executed at runtime without crashing with exceptions, but it contains logical error, as we illustrated in test case number 2 and test case number 1. Okay, that's something I want you to review very carefully before go on.